Okay, here we have our Yum's Bakery problem. Now I'm going to do this problem the way I would do it at the speed that I do these problems at. Maybe a little slower because I'm going to try to say everything I'm thinking. There is another video, a link available that shows a more explained process, but it takes a little over 25 minutes. So if you need to have more detail, watch the other video. If you can follow my thought process here and understand and do the problem, then apply that process to solve the Ace's guitar problem, which is the second page in the problems that I gave you, then that's fine. Just watch this one and you're good. If you don't understand my thought process here, you need more detail, watch the longer video. Alright, so we have this Yum's Bakery problem here. Yum's Bakery bakes two breads, A and B. We got one batch of A uses 5 pounds of oats and 3 pounds of flour. One batch of B uses 2 pounds of oats and 3 pounds of flour. And the company only has 180 pounds of oats and 135 pounds of flour available. I need to write the constraints for the problem and graph the feasible region. I must need some inequalities because I'm talking about a feasible region and constraints. Constraints will be my inequalities and the feasible region will be defined by those inequalities. Good. So now I need to figure out. If I'm going to write some inequalities and graph things, I need to have some variables. Let's figure out what my variables could be, and let's figure out what my limitations are. If I'm talking about constraints, I must have some limitations. Let's look for the limitations first. I've got a batch of A, I've got a batch of B. They use this amount each. Those are rates. Here we go. My company only has this much available. I only have 180 pounds of oats available. I only have 135 pounds of flour available. These are my limits right here. Good, good, good. So now I've got my limits. Let me see if I can find some variables in here. I've got a batch of bread A uses 5 pounds of oats. A batch of bread B uses 2 pounds of oats. So I know everything about what's available. I know what it takes to make these things, but I don't know how many of each batch I'm making. There we go. So X can be how many of batch A, or the number of batch A. I can make my Y, another variable, the number of batch B. Alright, good. So now let's look at my facts here. I've got two variables for my two types of bread. My X is going to represent my type A, my type A, and my B is going to be represented by my variable Y. The number of batches of A will be X, the number of batches of B will be Y. Now, let's see if I can start building my equations, my inequalities rather. In batch A, I use 5 pounds of oats. In batch B, I use 2 pounds of oats. For batch A, I use 3 pounds of flour, and I also use 3 pounds of flour for batch B. Alright, now I can start writing my inequalities. Here I've got 5 pounds of oats per batch A, and my number of batches of A is X. My B here, I've got 2 pounds of oats per batch B. My number of batches of B is Y. So 2 times the number of batches is the total amount of oats I'm using. And same here. So 5 pounds times the number of batches of A is the total number of oats I'm using there. So the total oats I use for batch A, the total oats I use for batch B cannot exceed or must be less than or equal to 180. Good. I like that table. Good. Now I can use the same process. 3x plus 3y, or the 3 pounds of flour per batch A, 3 pounds of flour per batch B, can't exceed 135 pounds total available. And in this scenario, my number of batches will never be negative. So I need to add number of A will never be negative. My number of batches of B will never be negative. X is greater than 0. Y is greater than 0. I'll make Y gray here. So now I need to graph these things. It's going to be a solid boundary line, and Y is the horizontal. Y is greater than 0, greater than or equal to 0. Boundary line is on a horizontal line there. X greater than or equal to 0. Boundary line is solid as well. Here, I want it to be greater than, so I need to go to the right. I want this to be greater than. I want to shade up. I'll wait to shade so it doesn't get too messy. can organize these here. Now I need to graph these things so I can find my feasible region. So I've got 5x plus 2y less than or equal to 180. 2y is less than or equal to negative 5x plus 180. Y is less than or equal to negative 5 half x 180 plus 90. There's 1. In my flower constraint, I'm going to get 3x plus 3y less than or equal to 135. 3y is less than or equal to negative 3x plus 135. Y is less than or equal to negative x plus, see, 40 takes me to 120, and then 5 takes me the rest of the way, so I need 135 divided by 3 is 45. And when I graph these, I need to make it a scale of 10 so my graph isn't too big. 10, 20, 30. My scales I'll make 10 so they're not as 30, 60, 70, 80, 90. So it's not too difficult to graph. 10, 20, 30, 40, 50, 60, 70, 80, 90. Now I'm going to graph this guy. Let's graph my other two constraints. My oats intercept, y-intercept is going to be at 90, and I'm going to go down 5 and over 2, or I can simplify that and say it's negative 2 halves, so I go down 1, 2 and a half, and over 1, 1, 2 and a half, and over 2, over 1 as well. Let me make sure 1, 2, 3, 4, 5, 1, 2, alright, I'm good. 1, 2 and a half over 1, and then this will take me below it. Let me connect these points. Nice straight, nice, reasonably straight line anyways. This will be less than, I need to shade down, less than or equal to, solid line, good to go. Now let's look at my other constraint. My intercept is 45, that's 45. I'm going to go down 1 over 1, down 1 over 1, down 1 over 1. Hey, they intersect. Alright, good. Down 1 over 1. There's a vertex. So they intersect right here. Now, that's all of my constraints. Let's look at what happens. My blue, I need to shade down. My green, I needed to shade down. My red, I shade right. My gray, I shade up. Here's my feasible region, right here. Right, so there's my feasible region. Now let's find my vertices. I'm dealing with an objective, a linear programming here. I'm going to have an objective function. Let's see where my vertices are then. See, I got one here, my intercept there, my origin is a vertex, this intersection, and then here, this intersection as well. Let's identify those things. This was the y-intercept for my flower, so that would be 0, 45. I've got my origin here as well. And then I have the intersection of the two lines, and that, when I graphed it, came out to be 30 and 15. That was my intersection. 30 and 15. And then I need to find my x-intercept for the oats. So that would be when x equals 0, or sorry, when y equals 0 here, I'm left with 5x is less than or equal to 180. Divide both by 5, that's 30, 30 remaining, so 36. So I end up with 36, 0. There's my vertexes, and I know that in a feasible region, if I have an objective function, which I'm going to develop, my maximum or minimum value will always be at one of the vertexes in that feasible region. So let's see if we can figure out what our objective function is. Yum's Bakery wants to maximize its profit. Profit. Like any business, they want to maximize their profit. Each batch of A yields a profit of $40. Well, I already have an equation or a variable for the number of batches of A. That's X. And they get $40 for every batch. So if I multiply 40 times the number of batches, that's the profit they get from the batches of A. Now I need batch B gives a profit of $30. So $30 per batch of bread B. $30 is my rate. Per batch of bread B, I have Y number of B batches. And this all has to equal a profit, so let's just call it P. So the total profit, or my objective function here, is going to be P equals 40x plus 30y. The number of batches of A times 40 plus the number of batches of B times 30 equals the total profit. Good, that makes sense. Now, let's evaluate that. My equation here, given these constraints, will be maximized at one of these vertexes. So first, I know that if I plug in 0 for both of these, I'm going to get 0 plus 0, and that's going to give me $0 profit. Let's look here. If I plug in 0 and 45, it's going to give me 40 times 0. So here we'll work this one out. Plus 30 times 45. Well, that's 0. And 0 plus 30 times 45 is going to be 1,350. So that means 1,350. 350 is my profit for 0 batches of A and 45 batches of B. Alright? Now, let's work it out the other way. If I have 40 batches, $40 of profit, and I make 30 batches of bread A, $30 of profit, and I make 15 batches of B, that's 1,200. 40 times 30 is 1,200, plus 30 times 15 is 450, so that gives me 1,650. Here it was 0 plus 1,350, just to fill in my table. So now I got 1,650, and on my last one, I've got 40 times 36 plus 30 times 0, and that's going to equal 40 times 36 is 1,440. So I've got 1440 plus 0 is just 1440. Alright, so my best profit comes from if I make 30 batches of bread A and 15 batches of bread B. That will maximize my profit given my constraints. I need to make 30 batches of bread A and 15 batches of bread B, and I will get $1,650 in profit. Terrible dollar sign. Terrible dollar sign. I'll get $1,615, $1,650 of profit. And that's my solution. This is my final solution. 30 batches of A and 15 batches of B will maximize my profit defined by the objective function given my constraints.